My name is Pawel Miech. So first I'll start with basic questions. Who am I and what is Scrapy? So I'm basically a software engineer working on Scrapy for a couple of years, basically contributing to open source projects. And I worked in Zeit, which is a company founded by Scrapy founders, so Shane and Pablo. The company was previously called Scraping Hub. And the next question is like, what is Scrapy? I thought maybe I'll talk about this. So just like question, how many of you actually used Scrapy? Okay, great. And how many of you use any other tools for scraping or engage in any kind of scraping? Okay. Is the microphone working now? Okay, working. All right. So so some of you already know it, but for those of you who haven't used Scrapy, Scrapy is like open source web scraping framework. At the moment, I think it's one of the most popular scraping framework, at least if you look at number of stars, if you take GitHub stars as a sort of criterion for popularity. It basically allows you to create HTTP crawlers that extract structured data from websites, and it can be used for data mining, monitoring, load testing. And basically it's really old framework, I think, like it was probably launched somewhere around 2010 or something like that, so it's one of the oldest probably open source scraping projects. And one thing to remember is that Scrapy is not to be confused with Scapy. Like Scapy is a packet manipulation library, and sometimes like some people actually confuse the two. So the talk is mostly about like new things that are going on in Scrapy that maybe you missed and that I think are interesting to highlight. One of them is Async IO support. So as you may know or may not know, basically Scrapy is based on Twisted, Twisted networking library. And Twisted is also kind of very old project. It was launched in 2001. And at some point we added support for Async IO, but it's still not common to actually use Async IO code in Scrapy, but just to let you know, it's actually possible. You can integrate Async IO libraries with Scrapy. And in the future, it will allow us to basically decouple Scrapy from Twisted and build more on top of Async IO. And about the reasons why it's useful, I'm going to clarify this a bit later. So in terms of new things that are going on, there's lots of other things that are cool and interesting that I'm not going to cover. Like if there are any good things you heard about, some tools you use or planning to release, let us know. You can maybe post them on Slido or somewhere else. But the other library I wanted to talk about is called Scrapy Poet. So first thing is basically about the Async IO, and I stole this from Czech and her talk about polars. So like that's the state of quite a lot of open source projects at the moment. So you have basically really complex modern digital infrastructure, and it's supported by some random guy who's working on it in his free time. So like I think like the case of Twisted Matrix and Twisted is kind of slightly similar to this. So I made a small refactor of that, like just to illustrate it. It's an AI generated picture, and as you see, like Scrapy is somewhere in the middle, and Twisted is somewhere at the bottom. And all the businesses making money is at the top of this. So I guess like you can ask about how many other projects have this kind of structure. I think it might be pretty common. Like if you look at how many libraries are actually underfunded and not supported in the way they should be, given their importance for the whole open source and programming ecosystem. So just like short digression about Twisted, like I just, when I was preparing this talk, I looked at the archive.com old webpage for Twisted, and it was like really interesting for me. Twisted was launched in 2001, and like you can see, they had this, that's the first archive.com page of Twisted. There are some testimonials there, like people are successful with Twisted, and it says there's the NASA testimonial there that they use some Twisted to go to space, so it was pretty fun. The version back then was Python 2.3, and yeah, and it was quite popular back then. And it was the only asynchronous library in Python back then, I think. So that's why it was logical for Scrapy to be built, to be based on Twisted. Other software from the time, I'm not sure if you remember. It was really cool, I really loved it. Winamp was also quite popular at this time. You could have those cool visualizations and skins. Like if you're a millennial, you probably remember. Right. So, but at the moment, like Twisted is probably not the main like go-to point if you're going asynchronous programming in Python. Like since Twisted was launched, Async IO is getting more and more popular, and like it's built in Python, so it's a kind of natural choice, right? So the future of Scrapy probably will look kind of more similar to this, and at some point the Twisted will have to be replaced by Async IO and Async IO libraries, right? Like someone could ask, like, why not do it straight away? And the reason for that is that there's lots of users and lots of projects that are still dependent on Twisted, and there's also lots of Scrapy code that's dependent on Twisted. So rewriting it takes some time. And also we need to prepare the users, people need to prepare and update their projects. And we all know how long it takes sometimes. Like I remember migration from Python 2, that there were still some projects running Python 2 long after the official end of life. So that's one of the problems of old frameworks, that you have to kind of take care of your users and the businesses that basically rely on your product. So that's the future for Scrapy, and it's like something worth considering. Like you can install Async IO reactor in your Scrapy project, and it's really worth doing that if you haven't already. Instead of using default built-in Twisted reactor, you just switch to Async IO reactor. Like in most cases I've seen, like everything works mostly okay, but there are some edge cases, like some plugins, middlewares, or some other tools that you have that are very custom for your project, and they might have some problems. So yeah, as with everything, you have to be careful with that. Yeah, so that's one thing. And the other thing I wanted to talk about is Scrapy Poet. That's one thing that we're working in Zeit at the moment. Like, so the company is basically started as a Scrapy, started around Scrapy. So it started around like building Scrapy spiders, but also providing infrastructure to run spiders and lots of tools for scraping. So we have quite a lot of Scrapy code, and we have quite a lot of Scrapy projects. And basically, the question is how to write those spiders and how to write the extraction code in a good way, which is like kind of easier to maintain. And I'm talking about the code that is parsing HTML, right? So extraction code specifically, because that's the kind of most problematic thing. So yeah, someone might ask, like, why do we actually need to write extraction code? And I think it's a good question, because I think in the future probably we don't have to. Like, I mean, you can do lots of things with machine learning, so you can just train your model on HTML and basically either generate the code automatically somehow or just extract the data using your machine learning approach. And I think like probably that's going to be the future, probably, and it's probably like the go-to approach, and we're also going in this direction. But like there are some limitations of that. So like one thing is that machine learning models usually need some kind of browser rendering to actually learn, and that's because sometimes the data is actually not accessible without browser rendering, because you have like single-page applications, AJAX requests, lots of kind of challenges. You can extract data from raw HTTP responses. You can train your model on that, but it's a bit more complicated and not always will get you all the data. The other reason is that sometimes you just have lots of extraction code and need to maintain it. And there are also cases where there's like a small number of websites that you need to crawl, and they don't have those common patterns. There's like lots of variety and small samples, so it's kind of difficult to train your models for. And the other reason is that sometimes the quality of ML-based extraction is not that high. Like sometimes people require very kind of fine-grained details and lots of kind of customization, so it's difficult to do with kind of a machine learning approach. So the question is how to write this extraction code. Yeah, well, the answer is probably like any other good code. So reusability, modularity, separation of concerns, and abstraction. So those are the basic things. But in practice, how do people write extraction code? Well, unfortunately, quite often it looks like this. I guess maybe in other areas it also looks like this. I suppose it's not just Scrapy projects that are spaghetti, but I think in case of extraction, it's quite easy to get into this kind of structure and this kind of spaghetti design pattern. And basically, that would be the spaghetti scrapy spider. I think the problem here is that with the concept of spider, it actually allows you to create those kind of monsters, because it's just, it allows you to basically put all your extraction and crawling logic in one place, in this spider object. And it doesn't really require you to kind of stick to like good patterns and to kind of like the solid design principles. So yeah, I thought I'm going to share like some spaghetti spider, because like usually on conferences you see good quality code, so I thought maybe it'll be interesting for you to see some spaghetti code as well sometimes. So I did some demo. I hope it will work. It should work. Right. So this is basically one example of spaghetti spider generated by ChatGPT, but it looks like, I just modified it to look like realistically. So you have some extraction code here, like you had some additional extraction, then you have some terrible if-else, and then you're making some request in the middle. That's very often, that's the big pain point in many scraping kind of spiders, that you're making requests in the middle and then you're doing something else. So you need to actually basically accommodate that. Then you extract more and more. You also like, it's usually even more complicated because sometimes you manipulate those field values, and then at the end you also make some other requests which are again extracting something, and again you have like some navigation somewhere and some kind of HTTP request and some kind of parsing, and it's all kind of mixed in one thing. So it's kind of difficult to maintain. And even if you want to refactor that, it's not that easy, because like people have different ideas how to refactor that and different standards. So someone will refactor that, but someone else will say, oh, I'll do it differently, and you end up with problems, right? So yeah, so that's the spider. Like here it parses again some things, and that's the full demo of the ugly spider, of the monster spider, and then right, then go on. Right, where's that? Here. Right. Yeah. So just to basically clear up this kind of bad like design pattern, the idea we had is basically to separate extraction from crawling, so that the navigation to website and all the HTTP request making and all the kind of functionality would be separated from actual extraction. And the reason for this is that it should make things easier to test. Like in this previous example, when you had this navigation mixed with extraction, it was quite hard to actually test just the extraction, right? Because we have some extraction, some request, and it was kind of, you would have to actually make all those requests to actually test things, right? Or you would have to mock them, which is also not great, right? Because it's kind of complicated, right? The other thing is easier development. So if you could test it, it's easier to develop, right? Like if you could just run your spider, like if you need to run your spider and make like 5 requests to extract some content and test it, it's really kind of slows down your development, right? Because request latency is always a problem, right? Reusability is another thing. So how are you going to reuse those parts from your spider that you have those extraction bits and pieces? It's probably impossible. And another thing is separation of concerns. So we basically separate I/O, HTTP network requests from extraction code. So basically the philosophy behind Scrapy Poet is that to allow you to separate that extraction from the navigation and all the HTTP request making. So you would have like, and it basically implements a page object pattern. It would be possible to basically isolate the extraction from the spider and just have like extractors, some similar place, modular and reusable. And spider, you could even have one spider that would basically do all the extraction. One demo of this is here. This would be like the good spider. Like, I have to say I'm cheating a little because it's just a simple example, right? And it's not like 50 or 60 fields, right? But I didn't want it to make it too complicated for demo purposes. But here's basically one example. Just pause. Yeah, so basically you have this page object here. It inherits from web page. So the news page class is basically, your page object. You have it separated from your news spider. So the crawling is basically in a separate place. And you try to basically make it separate. And now what I'm doing is basically running a test. So this is basically running, creating a test fixture. So when you run save fixture, it will basically run your spider. It will visit a page, and it will create and save, as it says on the end here. The test fixture has been written, right? So it creates a test based on the real existing website. It saves HTML content to some folder in your project, and it adds this set of tests. And then you can rerun those tests just for extraction without actually going to a page. So it will open up a page from your local folder without actually visiting this page, and it will run your tests. So if you break something, it's going to detect that, right? Which is not the case in like if you don't have tests, of course, right? Yeah. So just show you this. Okay. Yeah. So okay. Yeah. And the other benefit of those web pages is that they are not actually tied to Scrapy. So you could actually implement those Poet libraries in other languages. You could use any other downloaders. And that's actually something that's quite important for some use cases, that you could have some separate different downloader, not Scrapy, like HTTPX, request, Async IO, anything. And the idea is that the web page object that you write for Scrapy could be just taken from Scrapy and could be used somewhere else. And in the future, perhaps, you could also like basically use it in other languages as well, right? So you could have like one extraction code that you could reuse across like all different kind of HTTP languages, HTTP frameworks, or even programming languages. So for this to make like fully work, like there are some requirements, of course. Like ideally, you should have some common schemas, like for example, product schema or some other kind of things. Because like let's say you have this extractor for some product, and someone else has also needs this extractor, but they have some different data schema. Like maybe they need their fields are called differently, or they're extracting different data types. So for this, like it should also go with some kind of standardization of the extraction formats, right? And extraction data models, item definitions, right? So here we are trying to generate library for this, basically standardize item definitions. Like at the moment, there are just products and news articles, but in the future there can be more. It's just like everything can be standardized here, and basically you could just write that those extracts or publish them somewhere and reuse them without any kind of problems. Yeah, so I think I'm probably going close to my time, right? So at the end of the talk, I just like to encourage you to support open source and to basically remember that help is needed there at the bottom, usually, right? That there are some underfunded open source projects such as Twisted or any other tools. So yeah, support open source.
Thank you, Pavel. Let's move to the questions. As a Scrappy user with an already working crawler, what are the advantages to switching to Async IO?
Well, one advantage is that you can use some Async IO libraries, right? So that's one thing, right? If you can use, you can also use awaits libraries that are using awaits or any other Async IO syntax, and like some libraries at the moment are not working without Async IO. So like for example, the Scrapy Playwright library that I mentioned is not working without AI. I think it's not working at the moment. Maybe yeah, without Async IO. That's one thing. And the other thing is that it might become default reactor at some point. So at some point you might get into problems. Like it's not officially announced at the moment. So I don't want to scare you, right? So there's no official date. You're not going to suffer from it just yet. But in general, the direction is going slightly into moving into making everything Async IO, because it's just like de facto Python standard at the moment, I think. And Twisted is, I think, slowly, like it's just replaced by Async IO in many cases.
Okay. Are downloaders and extractors separated just in code? Can I download the whole website and then run the extractors on local files?
Yes, the answer is yes, and that's a nice thing about this. So you can basically download and the Scrapy Pattern save fixture command will do this for you. So it will basically download the website and then run extractor on the local files. So you don't have to test it, making requests to a website over and over again, which is quite inconvenient and inefficient sometimes.
Okay. There's no stupid questions. How would you argument for using Scrappy for extracting web content rather than URL lib2 plus Beautiful Soup?
Yeah, that's a very good question. So, I mean, probably the main advantage of Scrapy is that it's asynchronous. That's one thing. And the other thing is that it gives you quite a lot of built-in things that you probably might need, right? So if you're just going to use URL lib and Beautiful Soup, well, you need to probably handle redirect somehow, right? So let's say you make these requests, you get non-200 response code. Now, how are you going to handle that? You need to write some code to handle 302, 301. You need to add some code to handle retrying, right? Because the request can fail, so you need to retry. Duplicates filtering, so you're going to make some duplicate requests, especially if you have lots of things to crawl. It's quite often happens that basically you're going to visit the same pages twice, so you want to eliminate that. Caching, another thing. So there's like a really long kind of list of things that URL it's not going to do for you. But at the same time, like if your project is very simple and you don't need all those things, it should be fine, right? I mean, and you can also it's also a nice learning experience to actually write all those things in URL lib. I mean, I have some personal project where I tried to build some large crawler using just AIO HTTP without any crawling framework, and try to re-implement everything that you have in Scrapy, and it's actually quite fun, right? So if you don't need that, if your project is small, then maybe the simplicity of URL lib will work for you. And for Beautiful Soup specifically, you can use Beautiful Soup in Scrapy as well. Like many people don't know it, but you can. There's nothing stopping you from that. So if you don't like selector library, that is the default one, you can use Beautiful Soup, no problem. You just need to import it and specify it in your code, and it will work fine.
Thank you. Can you use it with Selenium and browser? Any advantage of Scrappy in that case?
Yeah. There are like some Scrapy plugins for that. I mentioned at the beginning Scrapy Playwright. That's for browser automation. Playwright is like probably one of the most popular headless browser automation frameworks at the moment. There's also Scrapy Puppeteer, and there's also Scrapy Selenium. So yeah, you can use it. In terms of advantages, the advantages is that you're going to get fully rendered HTML. So if you're crawling some page that has like lots of AJAX requests, the content is dynamically rendered, and there's nothing really in the raw HTTP response, it's going to be really useful for you because you don't have to like figure out like how to make those AJAX requests or look for something in JavaScript inside page. So yeah, that's the advantage. In terms of disadvantage, running browsers is quite heavy usually. So I mean, if you have a small scale, it should work fine, right? But if you have like larger number of requests, like you need to remember that on average, page probably has like, I'm not sure, like 100 or 200 requests, HTTP requests. Like if you're rendering one single page, sometimes it can make like 100 requests just to get all the CSS, images, lots and lots of other things. So it adds some load for your system, and it also will add some costs for you if you're running somewhere in the cloud. So that's the disadvantage of that. Yeah, and the other thing is maybe other disadvantage is actually managing browser farms. Because if you're going to get larger scale, you're probably going to need to manage those browsers, and managing browsers is complicated. Like think about just like 1,000 Google Chromes. Even if you're running Chrome on your local host, it crashes and it causes problems sometimes, right? And just think about having this like 1 million browsers running in cloud, right? They will crash. There are going to be problems with them.
Okay, thank you. Is scraping legal?
Yes. Yeah, that's a question to our legal department. So we have a legal department, and essentially, I'm not sure if I can. Yeah, but basically, if the data is public and if there are no terms prohibiting that, and if you're not like stealing something, of course, or doing some kind of abusive behaviors like some fraud or pretending that you're someone that you're not, or some other kind of bad things, then I think it's legal.
Okay. Doing scraping with Scrappy and without it, it's better to run it in 2 stages, crawl and store locally, than write and test extraction. What do you think?
What I found with 10, with 10, what's 10? Okay, so basically, in terms of running in 2 stages, crawl and store locally, yeah. That's basically the idea that I wanted to demonstrate. That the Scrapy Poet is basically probably designed for that kind of approach. So you run it, you store it locally, then you test extraction, right? So I completely agree with that. It's usually more efficient. But with Scrapy, in some cases, it's actually more challenging. But like, sometimes it's challenging because you have some complex use cases, and some people don't do it that way. So you just take Spider that's not written in a way that supports this kind of workflow. So that's the idea that Scrapy Poet should help with.
Okay. Dave wanted to tell you that he appreciates your choice of album on Winamp.
Yeah. Thanks. I really like. I think like Winamp is really popular. So happy to showcase good software, I guess. I thought about showing some other software from this time, but maybe another talk. It would be separate talk, right? Yeah.
Maybe on Lightning Talks.
Yeah.
Do you use Scrappy Redis or other schedulers?
Yeah. Scrapy Redis is really useful. Like we use Scrapy Redis. We also use some other schedulers. Yeah, basically there are some Kafka tools. Yeah.
Okay, again, the legal question. So creating a huge load by robots on target sites and increasing the AWS cost, is it still legal?
Well, as I said, like, those are questions for the legal department. Like, I'm not a lawyer, so in terms of, but as I said, like abusing someone's website is probably illegal, I guess, right? I mean, denial of service attacks are illegal, and by default, actually, Scrapy has built-in concurrency limits to prevent that, and it also has robot takes the obey, true, and kind of user agent, and lots of other practices around making it impossible. But of course, like if you're a hacker, you can do bad things with software. You can do it with any kind of software, right? So yeah, that's kind of probably, yeah.
Okay. And the last question: big search engines use Scrappy, or they develop their own tools? Do you know?
Well, it's actually a good question. Like, I don't really know what they use. I'm not sure what do they use, but I suspect they probably develop their own tools. But yeah, I guess, yeah, it's actually, I actually never thought about this. Like, maybe someone else knows, like, what does Google or Bing use? But I suspect, like, they have to use some browser rendering tools, and it's probably not an accident that 2 biggest headless browser automation frameworks are written by Google and Microsoft respectively, so Puppeteer and Playwright. So I suspect they probably develop Puppeteer and Playwright, and I guess probably for some websites, maybe they don't need browser rendering, and they just do raw HTML, HTTP response parsing. So that's my suspicion, but I don't know how it actually happens, and it probably requires kind of secret knowledge about the internals of those companies that the knowledge of that I don't have.
Okay. So that was last question. Thank you very much, Paweł.
Thank you very much.